All right, good morning, good afternoon. Good afternoon. All right, yesterday we were working on this and I think it's due on Friday. I thought I had posted the answers in Classroom, but I didn't, but they are posted now. So I did post them, so they are posted now. And yesterday I actually taught part of 10.2 and 10.3. So 10.2 is graphing square root functions, and 10.3 is graphing cube root. So that sheet was a practice of the graphing. So I want to take any questions you have about that sheet. First of all, I do want to show you something real quick though. I think I brought this up yesterday at the end, that if you have a square root function, I'm recommending that you draw a picture of the parent. And if there's a reflection over the x-axis, your final answer would look like that. And I'm recommending that if you have a reflection, just show that in your sketch. If you reflect over the y-axis, you should draw a picture to the left. So that helps a lot when you're only graphing 2 points, is to pay attention to not the left, right, up or down, or the vertical stretches or compressions. Pay attention to the reflections, and they will help you graph. All right, does anybody want me to graph a problem?
Could you do number 12 on that worksheet?
12 on this one?
Yes, please.
All right, so we state the points, the transformation. This is form 1. So this would be right 2. This is a vertical compression by 1/2. This is a reflection over the x. So this is going to be one of those problems where I show my little sketch at the beginning so I can keep track of what the graph's going to look like. And then finally up 1. So this is what I'm talking about. Square root looks like that. But because we have a reflection over the x, it's going to look like that. So that's our final graph. So I'm keeping that in mind. All right, now when you go to find the parent points, you know you cannot have a -1 under a square root. So that's out. So square root of 0 is 0. Square root of 1 is 1. So right 2 means add 2 to the x, add 2 to the x, and the y does not change. Vertical compression means multiply the y by 1/2. So the x stays the same, and you multiply y by 1/2, and you multiply y by 1/2. Reflect x is a vertical movement. So vertical means negate negate y, negate y. And then finally, up 1 means add 1 to the y. And on this one, 1 minus 1/2 is 1/2. So when you go to graph this, you're going right 2 up 1, and you're going right 3 up 1/2. And you know it looks like this. That's why we drew this. So if you're wondering, how's this graph go? You drew this to help you out. So it should look like it's falling. So now we state the domain and range. So the domain in range Some people are still having trouble with this, so pay attention. D comes before R in the alphabet, just like X comes before Y. So that's how you remember. Domain means X, range means Y. So the domain is where the graph exists left and right. Well, you don't see a graph over here. You see a graph starting at 2, going to the right forever. As far as the range goes, you see a graph going down forever. So that would be negative infinity up to 1 closed. So that's your domain and range. Now, somebody asked me, how do you know where the infinities go? Well, negative infinity always goes on the left, always. And positive infinity always goes on the right, always. Alessandra, did I answer your question?
Yeah, thank you. I was just having trouble with the transformations.
Okay. Let me just check my answer key to make sure I did it right. Yeah, that's right. Well, you know, with a vertical compression, you don't take the reciprocal. And remember, it's a compression if it's a proper fraction like 1/2, 2/3, 7/8, 7/9. Okay, can I erase this?
Yes, I got it down.
All right, anybody want me to work another problem? Last call. All right. Yesterday, did I put up the standard for lesson 10.2? Did I write the standard for 10.2 yesterday?
Yeah, I think you did.
California Common Core Standard F-IF.7b.
Yeah, you did, yeah.
All right, well, I'm not going to do any more graphs. All right, so you have to be able to graph in this chapter. And the other thing you have to do in this chapter, oh, do you guys want to see how to find the domain and range a different way? Okay, check this out. Let's say you didn't want to do a graph. Let's say they didn't ask you to graph and they asked for the domain and range. You don't want to have to graph. That's a pain. So check out this problem. All right, so let's say they don't ask you to graph. Let's say they ask for the domain and range. Well, here's what you can do. For the domain, the radicand, which is underneath the radical, x minus 3, we know it's positive, right, or equal to 0. Everybody agree? And if you think about this graph was shifted right 3. Well, if you set the radicand greater than or equal to 0, you can find the domain that way. So this is closed on 3 to infinity. If you want to find the range, this is a little trickier. Let me write it up here. You look at the radical and you set that greater than or equal to 0. And what you do is you build the function. Now, I know this is weird. I'm not winging this. I'm being very particular with what I'm saying. If I build the function, isn't the function y? Isn't the y the range? So check this out. I'm taking the radical and I'm making it greater than or equal to 0. And now I'm going to multiply both sides by 2. Well, if I multiply both sides by 2, 0 times 2 is just 0. And then what if I subtract 2 from both sides? Didn't I create the function? Yes or no? Didn't I create the function? Well, doesn't that mean that the function then is greater than or equal to 2? And doesn't that mean y is greater than or equal to negative 2? So there's your range. Your range is closed on negative 2 to infinity.
Wait, wouldn't you get a different answer if you did -2 and then you multiplied by 2? So how would you know which steps to do, like which one to do first to get the correct answer?
Well, you don't want to multiply a negative 2 by 2, so you're not going to subtract 2 first. The order matters. So you're going to want to multiply by 2 so you get a 0. Let me do it again.
But how do we know that? How do we know which order to go in, or is it just multiply first?
Multiply first, because I'm telling you. So if you did a negative 2 first, when you multiply by 2, you're going to get a negative 4, and you don't want that. So you're going to want to multiply first. So multiply both sides by 2. And then subtract 2 from both sides. So when you subtract 2 from both sides, you just built the function. And the function is g of x. And we know that g of x is y. So the range is closed on negative 2 to infinity.
Okay, thank you.
So the domain, you just set the radicand greater than or equal to 0. For the range, you set the radical greater than or equal to 0, and you have to build the function. So I'm just showing you how to do it in lieu of graphing. Do you want me to do another one, or are you guys okay?
Could you do another one, please?
Can you do another one?
Yeah, let's do another one. So what I'm talking about right now is I'm talking about finding the domain and range without having to graph. If they don't ask you to graph, you don't want to have to graph to get the domain and range. It's a pain. Let's do a problem that they never want to put in the book, except now. So they waited to now to put a problem like this. And we don't want to graph that. We don't want to go right to horizontal stretch by 2, reflect over the y and up 1. That's a lot of work. So if we just want to find the domain and range, the domain would be the radicand greater than or equal to 0 and solve for x. So the first thing you're going to do is multiply both sides by a negative 2. multiply both sides by a -2. Right?
Would the sign switch because you multiplied a negative?
Yes, the symbol flips. So you're absolutely right. You multiply both sides by a negative, you must flip the symbol. So now we solve for x, so we add 2 and add 2. So this is saying the domain is -infinity up to 2 closed. And this is correct, by the way. So that is correct. If we want to find the range, we take the radical and we set it equal to greater than or equal to 0, and we create the function. So all we have to do on this is add 1 to both sides. Okay, now the left side represents g of x, and g of x is y. So there's your range. It's closed on 1, up forever. Okay, now what I want to do is in this section, they're going to want you to write equations given the graph, like always. So they always throw this in there. Whenever they're having you do transformations, they always want you to write equations. Okay, any questions about this? All right, so here's the first one. So they want you to write a function in this form. G of x is equal to a times x minus h plus k. Now, we do know that is form 1. Doesn't matter that we know that. And they give us the graph of left 2 down 1 and left 1 up 2. So this is left 2 down 1, and this is left 1 up 2. Now, when we had the quadratic, the vertex was HK. When we had the cubic, it was the middle point. So guess what HK is here?
Left 2 down 1.
Yep. You're right. It's a starting point. So it's not the vertex, it's the starting point. It's -2 and k is -1. All right. So over here, do we know what B is? Well, we don't know what A is, but do we know what B is?
Is it 1?
And since we know 3 of the 4 parts, we can find A and write the equation. All right, so here we go. We're going to use the other point. Left 2 up 2 is our xy. We're going to plug it into this. So we're going to compute g of -1 is equal to A, we don't know, times the square root of x, which is -1, minus a -2 under the radical minus 1. So g of -1 is y, which in this case is 2. And what we have here is we have the square root of 1. Right? 2 minus 1? Minus 1. So the square root of 1 is 1, so we have 1a minus 1, which means a is equal to 3. So we can now write our function. So our function is g of x is equal to 3 times the square root of x minus a negative 2 minus 1. So our final answer is 3. Can you guys see this? Can you guys see this or not?
We can see it.
Okay. Okay, any questions? I will do another problem with the second form. Can I erase this? All right. So they want you to write a function in that form, and they give you this graph. Write one, down one, and the other point is what? 3/2 0. 3/2 is 1.5. All right, so as usual, we're going to find A, B, H, and K. So what's your H and K? With square root, it is the starting point, which is what?
1, negative 1.
What's B?
We don't know.
We don't know. And what's A?
1.
All right, so we're going to use the other point, 3/2 0. And we're going to put X is 3/2 in. And this is going to be the square root of 1 over B times 3/2 minus 1 minus 1. So this is Y, which is 0. But over here, you might want to get a common denominator. So I'm just going to take 3/2 minus 1 and get a common denominator, which would be 3/2 minus 2 over 2, which is a positive 1/2. Right? Right. Minus 1. So we're going to isolate the radical. So we're going to add 1. We're going to add 1. Where did the variable go?
Would it be
What am I doing?
B?
Huh? Oh, there it is. Okay, thanks. So it should be 3 over 2b? Yes, no?
I thought it'd be 1 over 2b because after we subtract 1 from 3/2.
Hold on. Yeah, so it's going to be 1 over b times 1/2. Is that correct? Yeah.
Yes.
So you would have the square root of 1 over 2b. So remember, when we're solving square roots, you have to isolate the radicals. So we're going to add 1. Add 1. Okay, now, there's a bunch of different things we could do. What I recommend you do is square both sides.
Wouldn't it be 1 equals radical 1 over 2b? Because it was still supposed to be 0 before we add 1 to the other side.
Oh, did I mess it up? This is still 0, right?
Yes.
Yeah.
So when you add 1, is that the point you're making?
Yes.
Okay, thank you. All right, so now we're going to square both sides. And when we do that, we get 1 is equal to 1 over 2b. Well, we just worked with rational equations, so can't you cross multiply when you have a proportion? This is a rational equation, right? So wouldn't that be 2b times 1 equals 1? So b equals 1/2? Follow that? So our function then is g of x equals the square root of 1 over 2 times x minus h plus k is minus 1. And you cannot leave that, you can't leave that complex fraction. So do you remember what I told you 1 over a fraction is? What's 1 over a fraction? It's the reciprocal, right? God, I'm listening. What is it?
The reciprocal, so it'd be 2.
2 times the quantity x minus 1 minus 1. And if you put this in the calculator and you set up the window right, you're going to get that graph I had up here. So this is the correct answer.
Miss Birch?
Hold on just a second. So this is that situation where the second form is always harder when you're writing the function. Go ahead.
Can you do a problem where where we find a and the square root doesn't equal 1?
Do you have a problem?
Oh no, because in the example you did where we find a, the square root equaled 1. And I just wanted to see how it looked like when it wouldn't equal 1.
All
Say it
right,
was,
let's find one in the
different
book.
numbers.
This is what, 10-2? Okay, look on page 501. Do you want to do B or do you want to do 7 on page 501? I'm asking you a question. Do you want to do B or do you want to do 7 on that page?
Let's do 7.
So the graph is left 3, up 5. And the other point is left 2, up 2. And this graph is falling. All right. So what's your H and K?
-3 and 5.
-3 and 5. What's A?
We don't know, but B is.
Right. All right. So we have G of X, which is -2, we're using the other point, is equal to A times the square root of X, which is -2 minus a -3. Plus 5. So 2 is equal to, it's going to come out to be a 1 again. Is that what you were saying?
Yeah.
Yeah, so yeah, I don't know of a problem. You have to find a problem for me to do. Because I don't know of one. So in this case, A equals -3. So your function would be G of X is equal to -3 times the square root of X plus 3 plus 5. Yeah, so you have to find a problem and ask me about it. Can I erase this? Okay, so that is the lesson. Class is over in 20 minutes. So we're going to go into the Math Wizard teams. And you're going to have to decide with your team. If you're not finished with this yet, you can work on this. Or you could start working the problems in the lesson 10.2. I have not posted that assignment yet. But we are going to do, in that assignment, we're going to do 1 through 17 all and 22. So it's going to be 1 through 7. I'll post it. As soon as I get out of here, I'll post the assignment. All right. And you guys decide, huh?
On what page?
10.2. So the assignment starts on page 505. Okay. So I'll see you in your teams. Like I said, you can either finish this up or you can start on the assignment. I think this, what we did the other day, this is due on Friday night. All right. I'll see you in your teams.